Hi, everybody. Welcome to Math 70. This video lecture is for section 5.2, which is about factoring quadratic expressions by hand. There are lots of good ways to factor a quadratic expression. Using a graph is a fantastic way. In this video, I'm going to show you how to do it by hand. So just as a reminder, a quadratic expression is a polynomial with degree equal to 2. So examples of that are, for example, the one I showed you in the video just now, x squared plus x minus 6. It doesn't have to be an x squared. It could be a number. It could be like 3x squared plus 12x minus 18. It has to have an x squared. It doesn't actually have to have an x term. It could be something like x squared plus 9. And it doesn't have to have a constant term either. You could have like 2x squared minus 8x. These are all quadratic expressions. The one we're going to focus on in this video is where the x squared is not multiplied by anything, and it has an x and also a constant term. So we call this form x squared plus bx plus c, where b and c are numbers. They can be positive or negative. So this video factors quadratic expressions of the form x squared plus bx plus c. Now, before we actually factor, we're going to go the other direction. And this is a reminder from the video on how to multiply polynomials. And if you remember from that video, I said I use the box method, or maybe I should call it the window method, because it's a great way to learn how to factor quadratic expressions. So let's do a review of the box method for multiplying polynomials. And they're going to be specific form of the form x plus a times x plus b. So I build my box. I have an x plus a that goes at the top and an x plus b that goes down the side. And I multiply each term. X times x is x squared. Ax in that window, bx in that window, and ab here. So I end up getting x squared plus ax plus bx plus ab. Let me give you an example with numbers. Let's do x plus 3 times x plus 7. So I'll build my box. X plus 3 along the top and x plus 7 down the side. I get an x squared, a 3x, a 7x, and a 21. And when I add up everything, I have x squared plus 3x plus 7x plus 21, which equals x squared plus 10x plus 21. Now, there's something really important to notice about this for factoring. First of all, 21 is what you get when you multiply the 3 times the 7. And 10 is what you get when you add the 3 and the 7. Let's do another one just to get that idea locked down. let's do x plus 2 times x plus 5. So I'll build my box. And I have x plus 2 along the top and x plus 5 down the side, which gives me x squared plus 2x plus 5x plus 10, which when I write it and combine the 2x and the 5x, I get x squared plus 7x plus 10. And notice that 10 is equal to 2 times 5, and 7 is equal to 2 plus 5. And that can give us a clue if we have to go backwards. So let's go backwards and let's factor x squared plus 7x plus 10 into the form x plus a times x plus b. To do this, I'm going to use the box in reverse. And this is the reason that I teach the box method, is because it's the easiest way to factor in reverse when you want to keep track of all your steps. So I want to take x squared plus 7x plus 10, and I want to write it as x plus something times x plus something. So I'm just going to write down the information I know, which is that x times x is x squared. And I also know that this number in the lower right-hand corner has to be 10, because it's the number times the number. So 10 has to be the a times the b, but 7 has to equal the a plus the b. So I'm looking for two numbers that multiply to 10 and add to 7. There are a lot of ways to approach this, but I'm going to recommend, if this is new to you or if it's proving a little challenging, that's okay. In that case, I'm going to recommend that you do this very systematically and you just start thinking, and by the way, this is a good reason to work on factors. You just start thinking about all the different numbers that can multiply to 10. 1 times 10 is 10. So is 2 times 5. And that's all I can think of in terms of whole numbers. So this is multiplication here. And then on the right side, we're going to do the addition. 1 plus 10 equals 11. And 2 plus 5 equals 7. So my numbers could be 1 and 10, but that doesn't add to 7. 2 plus 5 does add to 7. So that tells me that I have two numbers, 2 and 5, that multiply to 10, and 2 plus 5 adds to 7. That should be the letter B. Well, according to my box method, that must mean that these two panels in my box must be 2x and 5x, because I'm doing it in reverse, and that must mean the numbers along the top must be x plus 2, and along the side it must be x plus 7, which gives me x plus 2 times x plus 7 as my answer. I'm going to do another example just to show you again. The key here is to practice it a lot and make sure you're getting it right every time you practice. So you need to check your work so you're learning the correct way to do it. So let's factor, let's see, x squared plus 11x plus 24. So I set up my box. I'm going to build it in reverse. And one thing I know for sure is since I have an x squared here, it must be an x along the top and along the side. And since I have a 24 as my constant, it must be a 24 in the lower right panel of the box. And so I'm going to think of all the combinations that I can that multiply to be 24. That's 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. If I go any farther, yeah, the next one is 6 times 4, so I'm back to where I started. And now I'm going to say, of these combinations, which ones add to be 11? Aha, right there. 3 and 8 add to be 11. So that must mean that my other two panels are 3x and 8x. And so it must mean my factors are x plus 3 times x plus 8. And that's how you use the box method in reverse to figure out your factors. Now, I can change a couple things. I could change that, instead of being a positive 11x, I could make it a negative 11x. Instead of a positive 24, I could make it negative. So I'm going to show you examples where either the constant term or the coefficient on the x are negative. So let's factor, let's see, x squared plus 5x minus 14. I'm still going to use a box because that is going to help us every time. And again, if you have another method of doing this, that's okay. This is if you haven't developed a method yet. I find this to be pretty effective. So I know I have an x squared, so that means I have an x on the top and on the side. And now I have a negative 14 in the lower right panel. So I have to find numbers that multiply to be negative 14. Well, that could be negative 1 and 14. It could also be negative 2 and 7. It could be 1 and negative 14, or 2 and negative 7. So as soon as you have a negative number, or in general integers, you have to check integer multiplications, not just positive number multiplications. But still, I just check by adding across. Negative 1 plus 14 is 13. Negative 2 plus 7 is 5. 1 plus negative 14 is negative 13. And 2 plus negative 7 is negative 5. You probably could have stopped after the second one, but I like to show them all. Aha, negative 2 and 7. Those multiply to equal negative 14 and add to equal 5. And that means the other panels of my box must be negative 2x and 7x. So the top is now x minus 2, and the side is x plus 7. And so my factors are x minus 2 times x plus 7. And if you remember the video from before, what that means is that the x-intercepts of my parabola occur at positive 2 and negative 7, because you always switch the signs. And the y-intercept should be at negative 14. Don't worry too much about the scale, but it's going to look something like that. All right, we get a lot of information about what our function looks like from the two types of formulas. And the reason we factor is so we can find out what the x-intercepts are. Okay, let's do another one. Let's look at, for example, x squared minus 8x plus 15. So I'll do my box. I know I have an x squared, so that means I've got x's on the top and the side. And I have a 15 in the lower right panel. And so I need to find numbers that multiply to 15. So that could be 1 and 15 or 3 and 5. And I want them to add to be -8. So I'm going to do this kind of wrong at the beginning. Not kind of wrong, but I'm going to get stuck to show you how to get unstuck. So I check and I'm like, oh, this is close. 3 plus 5 is 8, but it's the wrong sign. Remember, just because we're working with numbers doesn't mean our pieces are going to be positive. So there are actually other sets of integers that multiply to be 15, -1 and -15. -1 times -15 is +15. So that's an option. And so -3 and -5, aha, when we add those together, I get -8. -3 times -5 is +15, and -3 plus -5 is -8. So in general, check positives and negatives. -3 and -5 work. That must mean my boxes are -3x and -5x, which means my terms are -3 and -5. And so my factored form is x minus 3 times x minus 5. Okay, let's see. Let's do another one. This one we're going to run into some problems because we're going to find that I cannot find the factors that work. Let's do x squared plus x plus 8. So I'm going to build my box. I know since it's an x squared, it must be x along the top and the side, and this 8 goes in the lower right-hand box. So I'm going to check my numbers. 1 times 8 works, as does 2 times 4. And I'll check my negatives as well, -1 and -8 and -2 and -4. Each pair multiplies to equal 8. But when I add them, none of these are going to work. None of these pairs add to equal 1. What do you do? And I have a very simple answer for you. You graph it. Graphing, using a graphical representation, is a very good way to do algebra. So I will share my Desmos screen with you. And we'll change this formula so it matches what was on the page, x squared plus x plus 8. There it is. There it's crossing at 8. That's what I wanted, right? That's the y-intercept. But notice it never touches the x-axis. There is no place where this parabola touches the x-axis. There is no x value that makes the parabola touch the x-axis, so there are no x-intercepts. This means that I cannot factor it. Because remember, factoring looks like x plus a times x plus b, where the a and the b, well, they're negatives, but this is where your function would touch the x-axis. And if it never touches the x-axis, you're never going to be able to write it this way. I'm going to switch back. Now that we've seen it, I'm going to draw it on my notes. Okay, so my graph looked like, and again, don't worry about the scale too much, but it looked kind of like this. And it never touches the x-axis, so it cannot be factored. But that's hard to recognize unless you graph it. And so graphing is an excellent way to approach quadratic expressions, especially if you try to do it by hand and it doesn't work. And there will be other times when I tell you graphing is going to be the best approach for solving this, for factoring this quadratic expression. All right, so I've showed you basically the four different types of quadratic expressions. We have something like an x squared plus x minus, I didn't want minus 6, what did I have as initial? X squared plus 7x plus 10, where it's all addition. And then we had an x squared plus 7x, sorry, x squared plus 5x minus 14, where that one was negative. We had an x squared minus 8x plus 15, where that one was negative. We could have them where they're both negative. Like, let's factor x squared minus 6x oh no, that's not going to work. Yeah, if I have these two negative, then pause. All right, I scribbled this out because I was about to talk about something and decided I didn't like what I was saying. So you may have noticed the video is edited just a little bit. So I was talking about the different types of quadratic functions we might see. One, maybe they're both positive, or where one term or the other is negative. And then sometimes, depending on the expression, you may find you have something that can't be factored with real numbers. And graphing is always a good way to get a sense for whether your expression can be factored and even what those factors are. All right, in our next video, we're going to look at other types of quadratic equations, things where you may not have a nice simple x squared. It might be something like 3x squared plus 12x plus 9. Or even worse, maybe it's going to be fractions. And what are we going to do when we see these types of expressions? That's for our next video. Thanks for watching.